everyone. My name is Epo Jemba, and perhaps, yes, here. Okay, there's no row. So yes, I will try to present you Nuun, which is a kernel that helps to organize big project, big software, and I will try to give you an overview because it's not possible to describe all of this work. So let's get started. So I am Epo Jemba. I am a freelance. I'm software architect and developer, and I'm working for 18 years on software architecture. I like DDD, domain-driven design, and good practice. And I'm the author of Nuun, like you know, and I'm the co-author of SeedStack and the creator of Business Framework. So what is Nuun? Nuun is a Java micro framework for designing enterprise class application and software stack. And it is based on the inversion of control architectural pattern. He helps organize the life cycle of application. He gives building blocks to organize the life cycle of an application. It is compatible with the major framework of the market, Spring, Juice, and so on. And we can connect all the injection framework that we want. And Nuun relies on the standard and proven component. GSR 330 via Juice. We are using Juice inside Nuun for the dependency injection. We are using service loader for discoverability. We are using reflections for class path scanning. And all of this is orchestrated by a kernel plugin protocol that I invented for managing extensibility, uncoupling, and cohesion. A little bit of history. When elaborating a software stack for major clients, I found out that the existing dependency injection framework was limited. We have a lack of explicit interface-driven injection. We have a lack of means to create my own convention, especially when I want to automate the creation of binding definition. That was not possible. We are string identifier that was error-prone when we are doing a lot of integration with a big project. And explicit configuration was in XML, so verbose, so I didn't want that. The auto-wiring was concise but slow, and it is not well suited for non-trivial application. And we cannot delegate the behavior. So why Nuun? Why I created Nuun? Because we need a clear and type-safe definition of the object graph, because Nuun is used to create the object graph of the application. In terms of dependency injection, aspect-oriented programming, and properties management, and more. We want a new experience for developer. We don't want developer spend a lot of time in configuration. We want developer use already the API they want. We want application just to be truly extensible and discoverable. We just want to add something in the POM dependency and it is working. And we also want to know how it works. We want a clean integration of the third-party framework without a bell and whistle. And we want also a sane software architecture. So that's why I created Nuun. So what are the Nuun building blocks? How Nuun is working? We have a runner, a simple runner, with an Entrypoint class. We introduce something interesting that is a meta scan to easily configure packages to scan. In another framework, you have to couple the definition of your package to scan to your binding definition. So I uncouple this. This is two separate things now. You can put your package to scan in this file and it will work. We propose two API, two levels of API. the Topology API, which is a nominal API for the application developer. Normally, you will want to use this because it is simple. I will show you this just after. And we have the kernel plugin API, which is a more advanced API and SPI aiming enterprise stack designer. This aim enterprise programmer. Nuun has been designed as an enterprise context, so the enterprise API has been designed first. A simple example, an example of the runner. So we have the Nuun runner, an entry point, and execute with args. As simple as that. An example of the Entrypoint, which is a simple class which implements runnable, and we have the standard at inject GSR 330, standard at inject for the service, the run, and that's all. So let me remember. So the injection we saw here are defined in a topology. And what is the topology? The topology API are declarative fragments of configuration, like you see in Spring config, in fact. But this, whereas here, topologies are interfaces. They are not classes because you don't have to test your configuration. This is just declarative. So you can declare all your binding definition, AOP, interceptor, properties, and so on. Let's see a sample. Here we have topology with a properties source. We are defining a server in string. So inside my application, HTTP Nuun IOD will be injected. We can define services. Here I see that internal Hello World services will be injected in a Hello World service key. And I can even inject optional. Here, the empty will be injected. And what is the result? So if I put my inject server with my qualifier, I will be injected with HTTP Nuun.io. Hello World service will have internal Hello World service as implementation, and here for the optional translate service, I will have the optional empty. So this is very simple. More advanced, I can define the injection of generics. I can define the injection of long. I can define the injection of implementation for qualified service. I can use provider from the GSR 330. And I can even use, I define interceptor. And this is how we will use it. Just at inject list service, and this is as simple. Meta scan is a directory that's interesting because you can, this file contains the list for the package to scan. And as I said before, this uncouple configuration from ClassPath scan directive. In your reusable component, you can put your meta scan, and the kernel will handle it. The kernel plugin API, which is the enterprise API. So what does the kernel do? The kernel is building the object graph of the application with the help of plugins from the class path. Like I said, the kernel is in charge of the object graph with the help of plugin. This is two interfaces. The usage is to create your kernel, launch the init phase, start it, and you can use the object graph method to get it. Here, this is a reduce injector. And then you stop it, as simple as that. So the kernel plugin protocol is very interesting. It is the main aspect, the main innovation of Nuun. First, the kernel is loaded from the class path. Then the kernel is loading all the plugins. Then all the plugins send requests to the kernel. A request can be, okay, let me find all the services that is like that or like that with the name ends with service or amp. Then the kernel is actually searching the class path and read for properties. After that, the kernel will return the result to the plugin. With the result, all the plugin will construct its own configuration, which is very local. So the content of the configuration are very in function of the environment. Then each plugin is returning back its own configuration to the kernel. The kernel is constructing a global configuration, and the kernel is building the injector. With this injector, the kernel we have our object graph, which is tailored for the application. So this is a deterministic runtime algorithm that lasts less than 200 microseconds. And plugins can communicate, and the protocol, this protocol brings an adaptive, resilient configuration system. The Enterprise API gives you the kernel lifecycle, parameters, kernel listener. I cannot detail all you have to organize or to create your own stack. You have an SPI with the plugin. You have concern, because with concern you can organize all your, what is a concern? Transaction is a concern, cache is a concern, security is a concern, so you can organize all your, okay. There's a stop here. So there is a lot of stuff you can do. Okay, toward 1.0. So Nuun is stable and used in production, but it is an incubation project in OW2. I have to finalize all the API and finish the documentation, blog and sample. It will be cool if I have someone who can test and have feedback from developers, because this is a developer stuff, and yes, feedback will be great. Thank you.